Okay, November progress test practice paper here. And we're asked initially to find the gradient of the line with the equation given. Okay, so we're going to rearrange this. Take our 2x across, plus 6. Then we just need to get y equals. We're always trying to get this into the form y equals mx plus c in order that we can read off the gradient. So we'll divide both sides by 3, which is 2x plus 6 all over 3. And then we can separate that into two fractions, 2x over 3 plus 6 over 3. And to find the gradient, all that we're interested in is the bit in front, the bit that's multiplied by the x. And in this case, I'll write it a little tidier in a way that we can maybe see it a little easier. That's the same as 2/3 x plus, well, 6 over 3 is 2, but that doesn't really matter for this one. That's your m value, your gradient. Gradient is 2 over 3. Note that it's not 2 over 3x. That is not the gradient. It's only the bit multiplied by the x. Is that 2 over 3 is your answer. Find the equation with a line. Find the line with gradient minus 3. So again, bringing up that y equals mx plus c form. And we can sub in the information we do have from the question. So that's our m value. That's our x value, and this is our y value. Just sub in those values. So 5 is equal to minus 3 upon 0 plus c. Well, minus 3 times 0 just disappears, so c is equal to 5. Sub that back in to our equation. Y is equal to minus 3x plus 5, and that's the equation of your line. Y equals minus 3x plus 5. Okay, using Pythagoras. So we're asked to find the length of the side AD. So we're asked to find the length of this side. So I'll just isolate that triangle first of all. We know that's going to be a right angle because that's a straight line across the bottom. So you get two right angles along the bottom. That's 10, that's 15. And we need to find AD. So we know that AD squared plus 10 squared has to equal 15 squared. So AD squared is going to be equal to 15 squared minus 10 squared. And AD is going to be equal to the square root of 15 squared minus 10 squared. Well, that's the square root of 225 minus 100, which equals 11.2. 11.2 is the length of the line AD. Now to calculate the angle BCD, well again, let's just isolate the triangle with BCD in. That was our B, that was our C, that was our D. And we're asked for the angle at C, so I'll just call that angle C, that's 12.5. And this is 10. So tan of C is equal to opposite over adjacent, which equals 10 over 12.5. So C is equal to tan to the minus 1 of 10 over 12.5. We plug it into our calculator, we'll see that that's 38.7 degrees. But the question asks us to give it correct to one significant figure. So 38.7 degrees to one significant figure is your 40 degrees, and that's your answer. Okay. So here we have one big triangle, but effectively we probably want to think of this as two smaller triangles where we're going to try and calculate the length of the line PQ. Now, essentially, using just the left-hand triangle at the moment, we don't have enough information to be able to calculate the length PQ. What we do have is more information on the right-hand side. So if we look just at QRS, we get 10 centimeters. 14 centimeters. And we can, because that's a right angle, we can use Pythagoras again. We can say QS squared plus 10 squared is equal to 14 squared. So QS is equal to the square root of 14 squared minus 10 squared, which equals, when you plug it into your calculator, that's 9.8 centimeters. And then using that length QS on the left-hand triangle, we have 5, we've got a right angle, we've got 9.8, and we want to know the length PQ. So PQ squared is equal to 9.8 squared plus 5 squared. So PQ, when you plug it into your calculator, you'll find that PQ squared is 121. And therefore PQ is just 11 centimeters. So your answer for that, length of PQ is 11. All right, completing the table of values for y is equal to 2x plus 3. Y equals 2x plus 3. Well, we're just subbing in the values of x we're given. We'll add a 3 there. And we'll just sub in the values of x that we're given to calculate the equivalent y values. So when we put minus 2 in here, we get 2 times minus 2 gives us minus 4. And then at plus 3 gives us minus 1. Okay. Plug in x equals 1 in here. And we get 2 times 1 is 2, plus 3 is 5. Okay, and do the same with x equals 2, and we get 7, x equals 3, and we get 9. And therefore, we just plot those points on our graph now. So minus 2, minus 1, minus 1, 1, 0, 3, 1, 5, 2, 7, and 3, 9. Okay, grab a ruler, straight line through those points. Straight as one note will allow me to make my ruler. Okay, so that's our line, y equals 2x plus 3. And it's good practice just to label the line like that. And then we're asked for the value of y when x equals minus 1.3. So we need to go to x equals minus 1.3. That's minus 1.1, minus 1.2, minus 1.3. Again, grab a ruler, stick that on x equals minus 1.3. Sketch up, sketch across from that point. And what do we have? Well, that is the point y equals 1.4. Oh, it's not 1.4, 0.4. Y equals 0.4. Okay, town B is 35 kilometers east and 8 kilometers north of town A, as per the diagram there. And we need to work out the bearing of town A from town B. So when we see from town B or from anything, we're thinking, right, we're drawing our north arrow at town B. If it's from town B, we're going to draw our north arrow at town B. And we're going to measure clockwise from that north arrow to the line joining B to A, as it is in this case. So that is the angle that we're interested in here. Now, obviously, we're not going to calculate that in a oneer. So what we can do is use our right angle trig rules to calculate this angle. And if that's our angle that we need to calculate, well, this is going to be our opposite and this is going to be our adjacent, isn't it? And if it's opposite and adjacent, therefore we know it's going to be tan of that angle theta is equal to opposite over adjacent, which equals 35 over 80. Theta, therefore, is equal to tan to the minus 1 of 35 over 80, which equals 23.6 degrees to the nearest degree, 24 degrees. So the angle theta is equal to 24 degrees, but we're asked for the bearing. Okay, we're asked for the bearing. So we know that we need to add 180. Because this bit here will be 180, and this bit is 24. So we do 180 plus 24 to find the bearing, which is 204 degrees. 204 degrees. That's your bearing. Okay, not dissimilar to previous examples. We've got one big triangle, but really we're going to view it as two smaller triangles and use the triangle for which we have the most information to find out things about the other triangle. So here we need to find the length of the line AB. Well, surprise, surprise, the triangle that we've got the most information on is the other one. So we're going to start with that. 32 degrees, 3.1 meters. And I'm going to try and find the line BD because that's the line that joins, or the line that's in common with both triangles. So of the angle 32 degrees, we have the, bear in mind that's a right angle, 3.1 meters is the hypotenuse, and BD is the opposite. Okay, if we're trying to find the opposite, we've got the hypotenuse, therefore it's going to be sine 32 is equal to opposite over hypotenuse, which is equal to BD over 3.1. BD is therefore equal to 3.1 sine 32, which is equal to 1.643 meters. Okay. That's your 1.643. So now we have that length BD, we can therefore use that to find the length AB in the left-hand triangle. So that's your AB. That's your right angle. It's 1.643. And that's the angle 42 degrees. Okay. Of the angle 42 degrees, this is our adjacent and this is our hypotenuse. Adjacent hypotenuse is going to use cos. Cos 42 is equal to 1.643 over the side AB, i.e. that's adjacent over hypotenuse. So AB, therefore, just rearranging this, AB is therefore going to be equal to 1.643 over cos 42. When you plug that into your calculator, you'll find that AB is equal to 2.21. Three significant figures, 2.21 is correct. And that's your answer. Okay, diagram shows isosceles triangle ABC. AB, side AB is equal to the side AC. So what that tells us is that if we have a vertical line drawn straight down the middle of our triangle, as we have here, you're going to have a right angle at the base of that triangle, base of that line on both sides. And these two angles are going to be equal. That angle is going to be equal to that one, and this length is going to be equal to that length. I think you probably look at that and think that's fairly intuitive, but just to be absolutely clear. So the height of the triangle is 6 centimeters, and we need to calculate the area of the triangle. So what we've got here in the 6 is the perpendicular height of the triangle. Area of a triangle is equal to half times the base times the perpendicular height. So we've already got this. That's the 6 centimeters. All we need to now find is the base. And to do that, we're going to take one of our triangles, like this, Let's say that's 6, that's 7.5, and this is our base, let's call it. And we've got a right angle there, so therefore we can use Pythagoras. 7.5 squared is equal to 6 squared plus the base squared. Well, the base, therefore, is equal to 7.5 squared minus 6 squared, and it's the square root of that. Square root 7.5 squared minus 6 squared, well, that's going to be 4.5 centimeters when you plug that into your calculator. Therefore, the total base, i.e. the line BC, is equal to 2 times the base of our single triangle. So therefore, the total base is 9 centimeters. And our area is equal to 1/2 times 6 times 9, which is equal to 27 centimeters squared. Okay, here's triangle LMN, where angle LMN is an obtuse angle. Okay, so I'm going to look at this. I'm going to think, right, I've got angle 47 and the side opposite is 13.8. Then I have side 8.5, which is opposite the angle theta. Okay, so I've therefore got a side which is opposite an angle and a side which is opposite an angle. So I can use the sine rule on that. 13.8 over sine 47 is equal to 8.5 over sine theta. And just rearranging this, when two fractions are equal to each other, we can multiply the top of one side by the bottom of the other, numerator of one side by the denominator of the other. So it's 13.8 sine theta is equal to 8.5 sine 47. Sine theta is equal to 8.5 sine 47 over 13.8. So theta is equal to sine to the minus 1 of all that, which is equal to 26.8 degrees. And it doesn't tell us, but our angle there is given, both the angles are given to full degrees, so we'll maybe do that as well. 27 degrees there. Then to calculate the length of the line LN, well, so we now know we've got, look at that angle's 47, that angle's 27, that angle there, well, that's going to be 180 minus 27 minus 47, so that's going to be 106 degrees, okay? And again, now we can use the sine rule to calculate the length of the side LN. Let's get that labeled right. So that's your L, that's your N, and that's your M. 8.5, 13.8, that's 13.8. So we can therefore use, right, we need side LN, and we have actually, by now we have two other pairs of length of the side with opposite angle, length of the side with opposite angle, so this will work. Ln over sine 106 is going to be equal to 13.8 over sine 47. Just completely by the way, equally you could have done sine 106 is equal to 8.5 over sine 27. And that will get you the same answer, okay? So Ln is equal to 13.8 sine 106 over sine 47. I'll just nudge this out of the way up here. And Ln, therefore, is equal to 18.1. We're asked to give our answer to three different figures. So we will say 18.1, and that's going to be centimeters. Okay, so we have one angle and the lengths of three sides here. So this is going to be cosine rule. All right, cosine rule, which is c squared is equal to a squared plus b squared minus 2ab cos c, cos of the angle c. All right, it should be large c because it's the angle. So let's sub in the values. Now we just know whenever we've got one angle and the length of three sides, it's going to be that. It has to be that. All right. So side small c is the side which is opposite the angle c. And as we've got the angle c is 60 in this case, our side c has to be the 2 root 7 squared is equal to 2x minus 1 squared plus 2x plus 1 squared minus 2 times 2x plus 1, so minus 1 just for consistency, 2x plus 1 times by the cos of 60 degrees, okay? Now, I haven't done that. All we are doing is just solving that, and it looks quite a lot at the moment, but there's nothing in here that we haven't covered if we just break it down in stages. So 2 times root 7 is 2 squared times by root 7 squared, okay, is equal to 2x minus 1 times 2x minus 1 plus 2x plus 1 times by 2x plus 1 minus 2. Well, 2x minus 1 times 2x plus 1 will give us 4x squared minus 1. That's the difference of two squares there. It's called the difference of two squares if you want to look that up as to why that's the 2x minus 1 upon 2x plus 1 simplifies to 4x squared minus 1 cos 60 degrees. Okay. So now I'm just continuing to tidy this up. Okay. What we find is that when we plug cos 60 into our calculators, that is actually equal to a half. Okay. So that cos 60 changes to a half and therefore cancels with the 2. 2 squared is equal to 4 times 7, well, root 7 times root 7 is just equal to 7. And we have 4x squared minus 4x plus 1 plus 4x squared plus 4x plus 1 minus 4x squared. The minus outside multiplied by the minus 1 inside gives us plus 1. 28 is equal to 4x squared plus 4x squared minus 4x squared. Well, those two 4x squares cancel, leaving us with 4x squared. The minus 4x cancels with plus 4x. The plus 1, so we've actually got plus 3 here. So plus 1, plus 1, plus 1, plus 3. So left with 28 is equal to 4x squared plus 3. So therefore 25, subtracting 3 from both sides, leaves us 25 is equal to 4x squared. And x squared is equal to square root 25 over 4. Square root top, square root the bottom. Oh, my bad. X is equal to the square root of 25 over 4, which is 5 over 2. Okay, which equals 2.5. X is equal to 2.5 there. Feels like quite a lot of work that for 3 marks, but so be it. Okay. Line 1, L1, y equals 6 minus 2x. And we're told that line L2 is perpendicular, so we know, let's change this into the form y equals mx plus c. So we're just going to rewrite and say y is minus 2x plus 6. And our m1, therefore, is equal to minus 2. If m1 is equal to minus 2, then m2 will be equal to minus 1 over 2. Okay, because we know that for perpendicular lines, m1 times m2 is equal to minus 1. If our m1 is equal to minus 2, which it is, times by m2 is equal to minus 1, then m2 has to be equal to a half. Okay, my bad. m2 is equal to a half. So and for the other points for L2, so we're going to sub it into y equals mx plus c, which is the general form of any straight line that we've looked at. And we know that the point line L2 passes through the point 4, 7. So we're going to be able to sub in x equals 4 and y equals 7 into our equation for line 2. So what we can write therefore is 7 is equal to a half times by 4 plus c. And this is all so we can calculate the c value of our line 2. So 7 is equal to 2 plus c. C is equal to 5. C equals 5. And the equation of line L2 is equal to a half x plus 5. All right. And what we're actually asked for is the coordinates of the point where the line L2 crosses the x-axis. Okay, so just looking at a quick graph, well, we know that our graph looks like that. The line, the x-axis, has coordinates y equal to 0. So we know that to find where the line L2 crosses the x-axis, we need to sub in y equals 0. 0 is equal to a half x plus 5. Minus 5 is equal to a half x. X is equal to minus 10. X is equal to minus 10. Okay. So, and find the coordinates of the point where the line L2 crosses the x-axis. Well, the x-axis, we find that the x value is minus 10. And we know that everywhere on the x-axis, y is equal to 0. So y is equal to 0. And that's your answer. Okay, 3D trigonometry. 3D trig. Almost there. Okay, let's see what we're actually being asked for here. So we're being asked for the angle that the line DE makes with the plane ABCD. So that is our line DE. Okay. And the triangle of interest to us is, well, that's the angle of interest. That's the angle that the line DE makes with the plane ABCD. And that triangle sits like this. Okay, sits like that. So we are going to try and calculate that angle at D, E, and B. All right, and that's a right angle. Now, what information do we have about that triangle at the moment? We don't actually have any of that information at the moment. But what we can calculate is if we look at the triangle ABE here, that's right, angle 30 degrees, that's 60 centimeters. This side BE is the same as the side BE in the triangle that we eventually need to calculate the angle in. And with this, we know that's a right angle, so we now have enough information to be able to calculate this side BE. And that's our adjacent, that's our opposite. So we know we're using tan 30 is equal to opposite over adjacent, which is equal to BE over 60. BE is equal to 60 tan 30. 60 tan 30 is 34.6. So BE is 34.6, 34.6. And the other triangle that we can use here is the triangle on the base of the prism, and it's this triangle DAB. Okay, where that's 60 centimeters, that's 60 centimeters, and we need to work out the length of the line DB. Obviously, we know two sides of a right angle triangle, so the length DB is just going to be Pythagoras. DB squared is equal to 60 squared plus 60 squared, which is equal to square root of 60 squared times 2 is equal to 7/200. Root 7/200 is equal to dB. Root answer is equal to 84.85 centimeters. So what that tells us is that our side dB is 84.85, and that is this side here that we've just calculated. Okay, and here it is on the same triangle drawn in 2D. So we now have two sides of the triangle DBE, and we just need to calculate the angle theta from that. So we have got the opposite, got the adjacent. Tan theta is equal to opposite over adjacent, which equals 34.6 over 84.85. And theta is equal to tan to the minus 1, 34.6 over 84.85. Tan to the minus 1 of 34.6 over 84.85 is equal to 22.2 degrees to 1 decimal place. Okay, tricky 3D trig question there. But fundamentally, bringing it all into 2D triangles, these are all triangles that we can solve using our basic right-angled trigonometry. And last question. All right. Right, we want to be super careful about exactly what we're asked to work out, first of all, here. Because we are asked, there's a number of ways we could be asked about this, and what we're asked for here is to work out the perimeter of the shaded segment, and to realize that the perimeter of that shaded segment is going to be the sum of the curved bit plus the straight bit. Okay, so there's a curved portion, curved bit there, plus the straight portion. Okay, and we are told that the area of the whole sector is 25 over 2 pi, and that the angle in the middle is 80 degrees. But notice that we're not told the radius, so we're going to have to use that information to find out what the radius is equal to. Well, so area of a sector is equal to, so the angle at the middle, which is 80, over 360 multiplied by pi times r squared. And we're told that that's equal to 25 over 2 pi. Okay, so I'll just continue working like this. So when we set that equation up, we have only got one unknown there, so we can use this equation to find out the radius of our sector. And if we have pi on both sides, which we can cancel off, that's great. Then we have 8 over, well, there's a 0 cancels top and bottom there. 8 over 36 doesn't go a whole number of times, but we know that r squared is equal to 25 over 2 times by 36 over 8. Okay, 25 over 2 times by 36 divided by 8, 56.25, and therefore the radius is the square root of that, which is 7.5. 7.5 centimeters is your radius. That's 7.5 there, 7.5 there. Cool, right. So that's the radius found out. And we now need to calculate we can use that to calculate some information about that triangle I've just shaded in. So we've got 7.5 is equal to, well, that angle is going to be 40. And we can now calculate this length here, okay, which would be the opposite. And that's the hypotenuse. So sine of 40 is equal to O over H, opposite over H. So the opposite is equal to 7.5 sine 40. 7.5 sine 40 is equal to 4.82 centimeters. So that whole straight edge then of the segment is equal to 2 times by 4.82 times by 2, which is equal to 9.64 centimeters. Okay, so that's a straight bit of the segment, and the curved bit of the segment curved portion is equal to 80 over 360. So that's the portion of the full circle times by 2 pi r. Okay, let's cancel the zeros there. We don't need those. We're left with 8 times 2 is 16 over 36 times by pi times by the radius of our circle. And we plug that into our calculator. We get 10.47 centimeters. That's our curved portion. Okay, so the overall perimeter is equal to the straight edge, 9.64, plus the curved edge, 10.47, which gives a total of 20.1 centimeters, which is correct to 3 significant figures. 20.1 centimeters, and that's your final answer.